Hello and welcome. In previous video I started configuring confederations, and I did the configuration of AS65013 specifically because this is a confederation which is in adjacency with some other autonomous systems. But here I just configured router 2 and router 5 between the pause, and after that I'm just going to configure this part. The configuration of router 2 and 5 of course are very simple, so I can just show it to you super fast. You can see that router 5 is in 65025 and the configuration ID is 100, which is the actual BGP autonomous system, and you can see that it is adjacent with 2, 3 and 7, and of course the network is advertised. The same thing about router 2. It is neighbor with router 1, 5 and 4, and of course this network is advertised. So this part is okay. So let's go to 4, 5, 7, and I just decided to have that router 4 is going to be my route reflector in here. So although I have different connections to other autonomous systems, and anything that router 6 receives, router 7 is going to receive, what I'm going to do is to, for example, disable this link later when I have adjacency with router AS400. Then I'm going to see whether the prefixes that are sent here are going to be received by router 7. This one is essential. So I'm going to configure router 12 as well. So let's just start this one as well. I'm going to do something about that later. So let's just open this one. Okay, so that's going to come up and later we are going to go to there. So let's go to router 4. Router 4 here is going to be neighbor with router 2, 6 and 7. So let's configure this. Enable configuration mode. Router BGP is going to be 6500467. This is the BGP identifier that we have here. So I'm going to hit enter, and then I'm going to say BGP router ID is going to be 4444, and BGP confederation identifier is going to be 100. BGP confederation peers are 65013, 65025. Okay, let's go with the neighbors. I can just go with peer group. In case I have multiple neighbors, peer group is going to be a very good approach. In this case, I have only 2 neighbors, which are going to be my route reflector. Another one is in another confederation. So that's okay. I'm not going to do anything special about that. So I'm going to say neighbor 2222, and this neighbor 2222, of course, is going to be in remote AES 65025. Later I'm going to show you one of the caveats which is going to happen here, but let's just do the configuration for now. I'm not going to do anything special about that for now, before I just show you what the problem might be. So that is this. The next one is 6. So neighbor 6666 is in remote AES 65467, and I'm using update source of 4444, and these two of course are my route reflector clients. I'm going to fix them, not this one, these two, 6 and 7 of course. Neighbor 7 and reaching to 7 is a little hard for my finger, is in remote is 65467, and of course I'm using update source of loopback, not loopback, the actual address 4444. Okay, let's go to address family now. Address family is going to be IPv4 unicast for now, and I'm going to activate each one of these. This one should be activated. This one should be activated, and finally this one should be activated. Okay. Okay, now I should say that 6 and 7 are route reflector clients as well. So I'm going to say This one is route reflector client, and this one is route reflector client. Okay, this part is done. I'm going to commit. Oh, before that, let's just advertise a network as well. So 4444/32 is going to be advertised. Now commit and save the configuration. Okay, we have configured these, so rather 6 and 7 are going to be configured. These are the final ones, and I'm trying to be pretty fast. So en configure terminal, rather BGP 65467, and BGP router ID, of course, is going to be 6666, and also BGP confederation identifier, which is 100. BGP confederation identifier, sorry, which is 100, and peers are going to be 65,013, 65,025. Now let's go for the neighbors. Okay, rather 6 is adjacent with 12. So, and that's adjacent, I should say neighbor as a matter of fact, but let's say neighbor 10, 6, 12. 12 is in remote AES. Is it 400? Yes. Remote AES 400. That is one of them. Neighbor 4444 is in remote AES 65467 with an update source of 6666. And that would be all, right? Yes, that's all. I'm not going to do any other adjacency, any neighborship actually. So, address family IPv4 unicast, and under that I should activate these. This one. Okay. And this one. Okay. And maybe I'm going to advertise 6666 into BGP as well. Okay, let's commit the configuration and save it. And finally, router 7 is going to be configured. Okay, router 7 is going to be configured like this. Router BGP 65467. BGP router ID is going to be 7777, and BGP confederation identifier is going to be 100. Also, peers are 65,013, 65,025 peers. Okay, let's go for the neighbors. I have a neighborship with 5 and 4. So neighbor 5555 is going to be in remote AES 65,025 with an update source of loopback. Not loopback, let's go with the actual ID, IP address. And neighbor 4444 is going to be in remote AES 65467 and update source of 7777. Okay, let's go to address family IPv4 unicast and activate these two. So this one should be activated. This one should be activated. And also the network is going to be 7777/32. Commit the configuration and save. The configuration is done, but there are pieces of configuration that we need to modify a little bit because there might be some problems. Let's see the problems. I'm going to start from router 4. Router 4 has 3 neighborship with 6, 7, and 2. So let's see if we have this. If I just go to router 4, and I'm going to say show BGP, and in case you see such weird characters like this, all you need to do is to just close this session and open it one more time. That's going to fix the problem. I'm going to bring it to this place, and I'm going to say show BGP IPv4 unicast summary, and hit enter. And also I should say terminal width is going to be 256, and do it one more time so that we have better thing. So you can see that I have adjacencies with 2, 6 and 7 without any problem. And if I want to see the prefixes, all of them are here. And the interesting thing is this one. You see that the IDs inside parentheses, these are confederation IDs, and the whole parenthesis is called confederation set. So you see that inside the confederation, not only can I see the confederations that a prefix has to go through, but the actual autonomous system number from the prefix is going to be visible here. So you see that 8888 is advertising autonomous system 200, then it has entered my autonomous system, and it has passed through different confederation to get to me. Okay, so that seems to be good. What about router 5, for example? Let's see this. OcNOS. And I should say again, terminal width is 256 so that we can see everything better. Show BGP IPv4 unicast. I just want to see the prefixes. Everything seems to be reachable. Everything seems to be good. What about adjacencies? Summary says that I have adjacencies with everything. Now, something that I should speak about is this. In case you are creating adjacencies using loopback, let's say, for example, between these two, you're using loopback interface, and these are treated as external BGP speakers. This means that from loopback to loopback, then TTL is going to be higher than 1. The rule says for eBGP adjacency, even between confederation, TTL is going to be set to 1. And sometimes you might see that. I didn't see this problem here, but I'm just showing you what if you see that. And sometimes you see that they do not really talk to each other because the TTL is going to expire in the middle of the path to get to the destination. There are two different solutions for that, and one of them, of course, you already know in case you want to use it. That's going to be eBGP multi-hop, and for multi-hop you can set a value or you can just leave it. If you leave it, the value is going to be by default 255, but if you want to go with specific value, you can say, for example, 2 or 3 or something like that. So eBGP multi-hop is going to be one of the solutions. The other one which you might want to consider in this case is disable connected check. Disable connected check is completely related to eBGP multi-hop, but you can use it separately. In case you say eBGP multi-hop, disable connected check is going to be activated by default. This means that it is not going to care whether the two neighbors are in the same subnet. In case, for example, you have neighbor in another subnet or far from you a little bit, disable connected check is going to be another option to be considered in solving this kind of a problem. But as you saw in my case, in OcNOS, of course, this is not the case. Let's just do something before finishing. And of course, I have not configured authentication. I'm going to do that as well. I'm just going to capture everything on Ethernet 1 and router 7. So I'm going to say capture Ethernet 1, and I'm going to wait for this to check some of the messages that are going from BGP. You can see that there is a TCP connection, this TCP connection is not going to be so interesting for us. So if I just open this, you can see that it is interesting for us because the source port is 179. This means that this is from BGP, and you can see that in this there are some interesting things, such as the source port, destination port, stuff like that. But what I was trying to find is the actual TTL of the message, which is not set in here. Maybe I can see it on here. So you can see that in this case, TTL is set to 1. But as I said, you don't really see any problem on OcNOS devices. But if you saw such thing, the two solutions that I told you are going to be used. The keep alive message, of course, if I just click on that, the keep alive message does have the same thing. So that's true about this. But again, that was okay in my case, and I didn't have any problem in that. And in case you have, either you just set eBGP multi-hop or disable connected check as the solutions. Next part of this asks us to configure authentication using this password. And like I said, that is super simple because that's just one line of command. And I'm just going to do it on one of the routers. Let's say between router 4 and 2. So I go to router 4. What I'm going to do is to go to configuration mode to router BGP 65,467. And if I show you the running configuration for router BGP, so I'm going to say neighbor 2222, and on some platforms you see there is a password option here. I don't have a password option here. The option that you are going to use is authentication key up here. So I just put it here, and it says what kind of an authentication key you are using. And in case, for example, you are going with password, it says that the BGP encrypted password key up to maximums here. I'm not using an encrypted password, so I have to say 0 first. And after that, it says what is the password. It is not encrypted anymore. In case you want to go with encrypted password, either type it or type 1 and after that type it. I'm going to say the password should be this, and I'm going to paste it and hit enter, and then I'm going to commit the configuration. Okay, now I need to do the same thing on the other side, but let's just do something before that. I'm going to say end and save. I'm going to say show IP BGP summary, and for router 2, now see that because of the authentication, the neighborship is dropped, and it is in connect mode. So let's do this on router 2 so that we have this as well. So I'm going to say OcNOS, and here if I just go back, you can see that I have router 4 configured as and a neighbor. So this is 65,025, and then I'm going to say neighbor 4444. Authentication key is going to be 0, or let me just paste everything here because I have just copied it here. Of course it should go away. Okay, so neighbor 4444, authentication key 0 because this is unencrypted, and then I'm going to hit enter and commit and end and save. Going back to router 4, trying this one more time. Now you can see that router 2 and router 4 are neighbors again without any problem. Okay, so with this, the tasks are completed, and we can just continue to the next video. So I hope this has been informative for you, and see you in next video.